Hello, this is Mr. Vanscoy. We're going to continue and really dive into our discussion on erosion and deposition. In this lesson, we're going to focus on moving water. When you are done with this lesson, the player can describe how gradient and velocity impacts the erosion power of moving water. You should also be able to describe how sediments are moved and deposited by moving water. Running water is a part, or moving water is a part of our hydrologic cycle, that is the water cycle. And we're going to take a look at how returning precipitation falls on the land and moves across the land and eventually to the oceans, along with a little bit of groundwater that might be coming up through springs. Some of this water moves over the surface and some of it moves through the ground as groundwater. We're going to focus more on the flowing water up on the surface. Flowing water does the work of both erosion and deposition. As that stream flows towards the ocean, they carry weathered materials. And I should note that as high school students, I'm kind of expecting that you already know the main parts of that hydrologic cycle, again, the water cycle. If you don't, I would spend some time kind of reviewing those main stages. So flowing water picks up and transports weathered materials by eroding mostly from the banks of those streams and rivers. Streams are going to be carrying a dissolved load, a suspended load, and a bed load. And we'll take a look at each of those here in a little more detail. We're first going to take a look at dissolved load. The dissolved load is composed of ions that are in solution. These ions are usually carried in the water all the way to the ocean. So these are going to be those invisible particles or very small particles that you're not really going to see. The bed load are the larger particles, too large to be carried as a suspended load. These are going to be bumped and pushed along the stream bed as a bed load. The bed load sediments do not move continuously. They move intermittently every so often. There's actually a name for that called saltation. You don't have to know that term. But streams with high velocities and stream gradients do a great deal of cutting down into the stream bed. So high velocity and steep gradients are going to cut down into the stream bed. And that's primarily accomplished by the movement of the particles that make up the bed load. So again, bed load going to be those bigger particles. The suspended load is going to be the sediments carried as solids as the stream flows. These are going to be the that brownish or sandy color, depending on the types of sediments it's carrying, that are going to give water usually its color, okay, in a stream. Especially after floods, you'll see a lot more suspended load. The size that can be carried as a suspended load is dependent on the stream's velocity. Faster streams can carry larger particles. Streams with a steep gradient or slope have a faster velocity and what's called greater competence. Rivers carry sand, silt, and clay as suspended loads. During flood stages, the suspended load typically increases because the stream velocity increases. And this picture here is a picture in Grand Rapids, Michigan of the Grand River, well beyond its normal flood stage. I think this picture was in either 2014 or 2013. As mentioned, rivers carry sand, silt, and clay as a suspended load until they reach the mouth or flow into another body of water. Here is a picture of some of those flooded rivers flowing out into Lake Michigan. So all of this brown out here, this is all suspended load. coming from the river running into it. And then eventually, as it comes out here, that velocity is going to decrease and all of the sediment will start to be deposited down on the lake bed. Usually headwaters are often high up in the mountains with very steep gradients, but there aren't any steep mountains in Michigan, or at least not in our part of Michigan. Here is actually the headwaters to the Muskegon River, which is the watershed that we live in. And the headwaters for the Muskegon River are actually Houghton Lake up to our north. As the stream moves into lower areas, the gradient's not as steep, usually less than 5% once you get downstream. Now the stream does more work eroding the edges of its banks. Many streams start to develop curves in their channels or bends in their channels that are called meanders. So all of these little S shapes, those are going to be meanders. At a meander, a stream actively erodes its outer banks and deposits materials along the inside curves. This causes meanders to migrate laterally or side to side over time. This stream has deposited larger materials such as gravel and pebbles along the inside curve of its meander. As the river moves onto flatter ground, the stream is going to erode those outer banks and can actually start to carve out a floodplain, which is a large, or not necessarily large, but it's a flat level area surrounding the main stream channel. The base level is where the stream finally meets a large body of standing water, usually the ocean, but again, same picture here. That I'd used before, but in our rivers, a lot of times they're going to reach one of the Great Lakes, and in this case, Lake Michigan. Streams work to cut down in their stream beds until they finally reach this base level. The higher the elevation, the farther the stream is from where it will reach its base level, and the more cutting it has to do. And again, in Michigan, it doesn't have to cut down too far before reaching the base level. As the gradient lowers, more of the material is going to be deposited. And again, rivers can flow out onto their floodplains. This is going to decrease the velocity quite a bit, and that's where a lot of the river's load is going to be deposited. And here is a picture, again, I think it's from the 2014 flood around the Muskegon River. You see this large flat area, and so once the river floods over the banks, it's got a wide area for it to spread out. So why would you want to build or live in this area? There's going to be a lot of rich nutrients on these floodplains. The deposits that are there, the minerals that are in those deposits are very good for the plants. So the Mississippi floodplain is heavily farmed, as is our floodplains here in Michigan. So although flooding can wipe out farms and towns, the stream also has deposits that are nutrient rich. The decrease in gradient causes the stream to deposit its sediments, the largest first. And this is true at the mouth of a stream too. It's always going to deposit those largest sediments first. But when there are floodplains, it can actually create natural levees along or out on those floodplains. As I'd mentioned before, when a river enters standing water, its velocity slows almost right to a stop. The stream moves back and forth across that area and drops its sediments in a wide triangular shaped deposit that's called a delta. All right, so now that you're done with this lesson, you should be able to describe how gradient and velocity impacts the erosion power of moving water, and describe how sediments are moved and deposited by moving water. As always, if you have more questions, please don't be afraid to ask.